everyone, welcome back to mahafarkar.co.in. In today's video, we are going to deal with one important parameter from the part of rotational dynamics, or we will call it from the part of rotational motion, that is moment of inertia. Now, moment of inertia or rotational inertia. Before discussing this, we should have to go through some definition. Say first definition is of rigid body. What is rigid body? In last year you must have familiar with these rigid bodies. Any object to which if you are applying force from different sides, different directions, and still there is no change in the shape, size or any kind of dimensions that takes place for that body, then that body is said to be rigid body. Means what? A body whose shape, size or dimensions remains same under action of forces, external force, then that body is called as what? Rigid body. When we deal with rigid body, that can be used for studying rotational motion. So just compare few things before going directly to the rotational motion or moment of inertia. Now, when we are at rest, which quantity provides you the inertia? Now you should know what is inertia. Inertia is the tendency of body to resist any kind of changes produced in its state. For example, if I am at rest, my body has maintained that state that I want to become at rest. This tendency is considered as what? Inertia. If fan is moving continuously and if you switch off it, it doesn't stop immediately because it has that fate that it was in a motion, and during that it don't want to come to rest. It is having inertia. Now to discuss this inertia in a rotational motion, some parameters are going to change. Remember, in linear motion, linear, or I will call it in a translational motion, mass provides inertia to the body. Mass provides what? Inertia. But now what is going to happen in the rotational motion? Then what is going to change in the rotational motion, that we are going to learn. So without now, let's go with the article of moment of inertia. For that imagine that we have a body of any shape, and that body of any shape is rotating about this point. I will call this point O is the axis of rotation. The point around which object is going to rotate is called as what? Axis of rotation. So it is rotating with certain constant angular velocity omega. Now say m is the total mass of body. M is what? Total mass of body. But to discuss the rotational motion for this entire body, as it is not having symmetrical shape, it is difficult to consider any distance because all the distances are changing. So for that, just imagine that body has different particles and of different masses situated at different distances. For example, body is made up of large number of particles, and every particle has mass m1, m2, m3 up to say mn, and all the particles are situated at different distances, r1, r2, r3 or rn. Okay, so let m1, m2 up to mn be the particles of body situated at distances r1, r2 up to rn from axis of rotation. Then here we are going to define one term called moment of inertia. So according to the definition of moment of inertia is product of two things. So moment of inertia, mi of body, or here I will write mi of particle. mi of particle is what? Is the product of mass of the particle, and square of distance of that particle from the axis of rotation. So if I want to find out moment of inertia for first particle, so it is indicated by I1. So it is indicated by what? I1. Then if I want to write the definition, then according to the definition, moment of inertia for that first particle is given by formula m1 into r1 square. It is given by formula m1 into r1 square. Similarly, if I want to find out moment of inertia for second particle, then I will write m2 into r2 square. If it is to be found out for nth particle, then I will say it is mn into rn square. See, what is moment of inertia then? It is the product of two things. Which is the first thing? It is the mass. First thing that we have to consider the mass of that object. And second thing, the square of distance of that object from axis of rotation. Square of distance from what? Axis of rotation. So here we consider that particle of mass m1 is at distance r1 from the axis of rotation. Mass m2 is at distance r2. All the distances are perpendicular. For example, if I am having any object like this, so if this is the axis of rotation, if I consider this marker as axis of rotation and my hand is going to rotate around this, then all the distances are perpendicular. This is another marker. These are particles situated there. Okay. So if this is the first particle, second particle, then this marker mass m1, distance r1, perpendicular. Okay. So if I want to find out moment of inertia of body, therefore mi of body, then mi of body can be given as I equal to addition of all these I1 plus I2 plus up to In. Substituting all the values, I will write m1 r1 square plus m2 r2 square up to mn rn square. So I can write this in the combined form like summation of mi ri square from I equal to 1 to n. Summation of mi ri square from I equal to 1 to n. In general, if I take total mass is m and all the particles are at average distance r from the axis of rotation, then moment of inertia is defined as I equal to mr square, mass into distance square. SI unit from this can be written as kilogram into meter square. The dimensions from this can be written as mass, that is m1, length, that is L2, time doesn't require, so T0. This is what moment of inertia. Okay. We are going to study physical significance of moment of inertia. What exactly significance? Why moment of inertia is important in the rotational motion, that we are going to discuss. To discuss that, I have made already one table, and in that table you can see linear motion and rotational motion is compared. Okay. Now, what you see there, in a linear motion, if m is the mass of object moving with certain acceleration, then force is required in the linear motion given by formula mass into acceleration. But now if you compare the same in the rotational motion, then that force which is used in the linear motion is changed as torque. It is changed as what? Torque. And this torque is given by formula that you are going to derive in some next article. The torque is equals to I into alpha. Now see, this I has taken the position of m. I has taken the position of what? M. So the inertia which was provided in the linear motion is by mass of the object, whereas inertia in the rotational motion is provided by what? I. The same we can compare for another example. Linear momentum in the linear motion is given by product of mass into velocity, whereas angular momentum is given by I into omega. So again, mass is replaced by I, linear velocity replaced by angular velocity. Kinetic energy of rotating body is given, linear motion is given by half mv square, but kinetic energy of rotating body given by formula half I omega square. So what we can conclude from this, that first thing that we can conclude is moment of inertia, mi of body in a rotational motion, body in rotational motion has similar function as that of mass in a linear motion. This is one of the most important significance. So in very simple words, if you are getting inertia in linear motion, then it is because of mass only. But in the rotational motion, that inertia you are getting because of what? Moment of inertia. In short, you can write it as mr. Okay. Now, secondly, what moment of inertia describes for us? Then it gives the basic details, basic idea how that distribution of mass is there. More the value of moment of inertia indicates more the object is situated away from the axis of rotation. मोमेंट ऑफ इनर्शिया जेवढा जास्त असेल याचा अर्थ तुम्ही म्हणणार की तो ऑब्जेक्ट ऍक्सिस ऑफ रोटेशन पासून लांब आहे किंवा त्याच्या तो पार्टिकल ऍक्सिस ऑफ रोटेशन पासून लांबच्या डिस्टन्सला प्रेझेंट आहे. ओके. डिस्ट्रीब्यूशन ऑफ मास also can be studied with the help of moment of inertia. Then if instead of writing objects of masses m1 m2 up to mn, if suppose I say dm is the mass of each small particle situated at average distance r, then in that case instead of using summation symbol what we have used previously, I can use the integration that r square into dm. This will also be with the formula for integration, finding moment of inertia using integration, that we are going to use in some next article. I hope you understood this. Moment of inertia, again in short, if you want to define, I will just revise that. It is the product of two quantities. Which are the two quantities? First is the mass and second is the distance of distance. But not only distance, we have to find out square of that distance, and therefore moment of inertia of a rotating body is defined as the product of mass of the body and square of perpendicular distance from the axis of rotation. Therefore, moment of inertia I is equals to m into r square, where m is the mass and r is the distance square. Okay. Now, SI unit according to that will be kilogram into meter square. Dimensions will be m1, l2 and t0. I hope you understood this article. Thanks for watching mahafarka.co.in. Have a nice day. Thank you.